Okay. So in your laptop, if you give the command net start, right, it will show you like this. Okay. So which means I was telling you that TCP is connection oriented protocol, right? Connection oriented protocol. Okay. So which means TCP is reliable. Okay. And what TCP does is I can say the functionality functions. You can say functions is it does flow control, congestion control, and error detection. Okay, these are the three functionalities of TCP. We will see one by one, right? Okay, so before I told you that TCP establishes the connection before sending or receiving the data, right? So if you see in this net start, right? So I see something like local address, foreign address. So local address is my local IP 192.168. Right, 29.248.50.962, right, and here the server IP is 51.105.71.136, and your port number is HTTP itself. Okay, so first here what happens? It establishes the three-way handshake, right? This is SYN, this is acknowledgement, and SYN, right? And this guy will send acknowledgement, right? So here you have to notice that we have given IP colon, this one is, we call it as port number, and this one also port number. Okay, so let me discuss what is port number. See, see, so your header is totally 32 bits from here to here, right? It's 32 bits. In this 32 bit, this is port number 16 bits, and your destination is 16 bits. Okay, which means port number is 12 bits. So 2 power 12, 65,536. Okay, so port number starts from 0 to 65,535, right? This is the range of your port numbers, which means 0 to 65,535. Correct, these are the range of your port number. And in port number, right? So these are that port number, this one and this one. Okay, Okay. So these are the port numbers, 16 bits, right? So the range is 0 to 535, right? So if you see here, there is a number. There is a number with called 50962. What is this number? This also port number, and here we saw it's a HTTP. Yes, right. What does it mean? See, so in the 0 to 65,536, 535, right? 0 to 1023, we call it as well-known port number. Well-known port numbers. Okay. So in this well-known port numbers means the port numbers are defined for particular services. For example, if I say the port number 53, that port number is used for DNS. Okay. If I say telnet, that port number is used for 22 is the port number used for telnet. And if I say SSH, SSH uses the port number 23. Okay. And HTTP, this this protocol uses 80, port number 80, and HTTPS uses 443. Clear? So which means the services will be identified with the with the port numbers, right? If I say destination 443, your computer or your system, whatever the system, he understood, okay, this guy wants to use the protocol HTTPS. That's why it showed HTTPS here, right? So if you see here, it shows, here it shows the port number, but here it shows the HTTPS, because your systems know that port number 443 is reserved for HTTPS protocol. Clear? That's why it understands the 443 and straight away it shows HTTPS in your destination port number. Clear? Guys, clear? If you have any questions or if you're not clear, please just ask me. I will explain, no problem. Okay. So, all good?
Yeah, good.
Okay. So, okay. So the point here you need to remember is port number is 16 bits. Okay. So if you're writing the CCNA exam, if you're planning to give the CCNA exam, a few questions will be they will be asking few questions from this port number, like 53. What is this port number for? Like you should say like it is used for DNS, right? And HTTP 80, right? HTTPS 443, and there are plenty of uh, port numbers are there. It's a very big list, so I'm writing few of the port numbers which is very important to networking guys, right? So these are the port numbers, and we can say SNMP, check for SNMP, SMTP, take it as a homework just to see what is the port number for SNMP, SMTP, and syslog, right? So these are the port, and the FTP, right? FTP, if you say FTP, it is 2122. Okay, so this is for secure channel, this is for secure channel, this is for normal FTP, right? So these are the port numbers, right? So this is my computer, this is my laptop, now this is my server, right? This is client server model. Okay, right? So SYN packet acknowledgement plus SYN and acknowledgement. Clear? And this is my 192.168.29.248 port number 50931. This is the random port number, and here is 50.21.28.19 here it says HTTPS. Okay, so meaning that my source port number is a random source port. My source port number would be always a random one, random port number. It is a randomly selected random port number, right? So my destination port number is well-known port number, correct? Well-known port number, right? So HTTPS. So well-known port number. So that's why it is 443. Well-known port numbers are recognized by your networking devices. Okay, so that's how it is. 16-bit, and this one is 16-bit. Now I told you that the original data will be segmented in TCP. Correct? If I say if this is my data, I told you it follows some numbering systems. 1, 2, 3, 4, like, right? So which means you are assigning some numbers to each segment, correct? So this is your raw data, and you are assigning some kind of some numbers to each segment. Okay, so that this guy will send you this number, and by using this number at the client side, you will reconstruct this data, correct? So this number, we call it as sequence number, and this is 32-bit. Clear? I told you that your data will be segmented. It will be divided into different segments, and TCP follows a numbering on kind of numbering system, right? That number we call it as sequence number, and this is 32-bit. Clear? So this sequence number is you cannot predict. Computer selects some random number. So for the sake of understanding, I just told you that 1, 2, 3, 4, 5, and 6, but you don't know which number it will pick while segmenting the data, right? So the sequence number is, this is also random number. Nobody can understand. So nobody can predict before that. Why? Why it is in random nature? To avoid, to prevent session hijacking. There are threats in internet, right? So they will prevent you from hijacking. So if you know this sequence number, every time it starts from 0 to and it will goes on, then you are giving some you are giving some clue to your hackers or someone from the internet, right? So that they can predict this number, they can hijack this, or this guy will inject their session into this, right? Session injection will happen, right? So this kind of threats are there. That's why they kept this sequence number as a random value. So you cannot predict what number the TCP selects for segmenting the raw data. Clear? So I will show you all this using the using the tool called Wireshark. We'll see all this. Once we discuss all this TCP, I will show you this sequence number and port number, everything. Okay. So what is this acknowledgement number? I told you the TCP is a reliable protocol, right? Which means it's a connection oriented protocol, right? So which means, for example, if this is my raw data, and if you, and the one is my sequence number, right? After this three-way handshake done, after this three-way handshake, now you have to send your data, right? Original data. After this three-way handshake done, you have to send your original data to the guy who is requesting the data, correct? Now let's say server is sending the data, right? Now what happens? He will send uh, let's say this is your raw data. Now you are sending the sequence number 1, right? So this guy first sends sequence number 1. Once this guy is received this sequence number 1, which means this first number, he will acknowledge this guy, hey, I received sequence number 1, this is my acknowledgement. Then what this guy does, this guy sends segment number 2 and your client receive it, and this guy will reply you back with acknowledgement number 2. Clear? Clear, guys?
Uh, yes, Manu.
Okay. So now this guy sends. Let me draw this even better. That would be easy for you guys to. Guys, my handwriting, everything, it's not that bad, right? It's fine, right? At least you can understand, correct?
Yes.
Okay, thank you. Let's say this is client side. This one is server side. Okay, so which means this is my PC. Okay, this is my source IP. I can say source port number 502948, something like this. And server, this is my server. Let's say 50.21.29.12, and my destination port number is 443, which is HTTPS. Okay, now what happened? First, what happened? It will send SYNAC acknowledgement. SYN acknowledgement for SYN and SYNAC, and then acknowledgement. Now the original data transfer happens, right? First, what happened? This guy will send sequence number 1. This guy acknowledges this sequence number 1, and this guy, once he receives the acknowledgement 1, then this guy sends sequence number 2. Then he will acknowledgement back with sequence number 2. Clear? So like this, okay, like this it goes on till the last segment. Let's say my last segment is 15. Then this guy will send the last sequence number 15, and this guy will receive the acknowledgement for 15. Correct? So in this way, all your 15 segments will be transmitted from server to, you are transmitting, right? So you are transmitting all the data to, all the raw data to client by segmenting this by segmenting this using the sequence number, right? You are sending from server to client, and for every sequence number you are receiving the acknowledgement saying that, hey, I received the sequence number 1, now you can send me the sequence number 2, which means it is reliable. Correct? So you are getting the acknowledgement, you are getting the confirmation for each segment of data, right? So once this is done, right, once this is done, right, now what happens? Now you received all the data, right? For example, if you are downloading any movie, right? If you are downloading any movie, this one is the data, it means. So once you're done with downloading the entire movie, right? Now what happens finally? The connection, this connection you established, right? This has to be terminated. Once the data transfer happen, the connection should not be there. It should be terminated, right? So we call it as, like how you are establishes the connection, in the same way the connection has to be terminated. We call it that in TCP connection termination, right? So connection closes or termination, whatever, close connection, whatever, right? It's a three-way handshake. Again, connection establishment is three-way, and connection close or connection termination also a three-way handshake. Sometimes it is four-way handshake. Depends upon the systems what you are using. Okay. So here, which bit you are gonna use? This guy say fin. This guy say acknowledgement plus fin, and this guy say acknowledgement. Okay. This is the connection termination part. This one is the connection establishment part. Okay. And this one is data transfer part. So this is how TCP works. Yes, any questions so far? All good? Joshua, Enamel, Khalil, Rahman.
Understand, Madan.
Yes.
Yes, I am okay.
Okay.
Uh,
Okay. So my question is, what happens if I lost this sequence number 2? You understand? Because basically, anyhow, this client and server are will be connected through some kind of copper or fiber, right? Right? Because at the end of the day, you are going to connect your internet either with the Wi-Fi, either with the fiber, or either with the copper cable. Correct? And server also, you are either it will be connected with the copper, fiber, or I don't think server connected via this Wi-Fi, but so either you have to use any kind of connection, correct? So there are chances the data might get lost in the transit from source to destination, correct? There might be chances, one or two packets or some, if anything, if for example, if you are using the fiber optics cable, right? For example, if you are using the fiber optic cable, you should not bend this cable. You should not twist this cable, right? So there is a ratio called refraction index. There is a term called refraction index, right? So it should be, I think it should be 1. Even if you twist the cable, bend the cable, it should satisfy the value like refraction index something equal to 1. If you bend it right, the light which is passing inside will be scattered out. If the light is scattered out, it's kind of your data loss, right? That's why you should not bend the cable, fiber cable, right? So you don't know, something might happen in the transit. In that case, if you are losing some data, then your sequence number, this data, so this let's say this 3 is lost in the middle, which means you will not get, you will the client will not receive this sequence number 2, correct? No, it's a 3, right? Yeah, let's say it's 2. If you are losing, if 2 is lost in the transit, then this guy will not receive the sequence number 2 at the client side, correct.
Mhm.
Yes.
So in this case, the sequence number 2 is lost, and the server is waiting for the acknowledgement to receive for the sequence number he sent, right? The thing is, the sequence number will not be reachable here because we lost this sequence number 2 in the transit. Now how long this server should wait? There should be some time to wait, right? He cannot wait like infinite time, right? So that is called timeout, right? The exact name is retransmission timeout, and in here also you see some kind of timeouts and all, right? So which means this is the timeout, right? Actually this name, the exact name is retransmission retransmission timeout. Okay, so let's say this is some it will be it calculates internally. It is automatically picks some value and he will wait. Depends upon the latency value from SYN and DAC, right? So let's say this is 1 microsecond or 1 millisecond. For the sake of understanding, I'm telling you. Okay, so it will wait till 1 millisecond. If he is not receiving the acknowledgement back within this 1 millisecond, right? What happens? This guy will again send this sequence number 2 after this retransmission time. After this retransmission time expires, right? Again, this guy sends the sequence number 2 again. That's why we call it as TCP as a reliable connection. Okay, reliable. Why? Because your data will not be lost. It is your segments will not be lost. It is very reliable connect. This connection is very reliable, but you can expect some delay in this because if anything is if anything any segment losing in the transit means again you are waiting for some time and again you are sending that sequence number back to your client, right? That's why the delay happens. Okay, and this is why we call it as a reliable connection, right? Which means now let's come here. So if that timeout is expired, right? Again, this guy sends this sequence number back to your client. Correct. This is how you are really receiving this last segments. Now another scenario. If the cable is broken, if the cable is broken into two parts, do you expect the acknowledgement two again? If though you are sending this sequence number two again, do you expect the acknowledgement to back? Because its label is broken, nothing will happen, right? So your data will not be sent or received. So how long this server keep on sending this sequence number to? There should be limit, right? So this retransmission happens 16 times. So the first point is, if this guy is losing this segment in the transit, this guy waits for some time. That time we call it as retransmission timeout. We'll send that sequence number again after this is retransmission time expires. Okay, once it is done, this guy will send the sequence number again to this client. So this will happen 16 times. If you receive the acknowledgement within this 16 attempt, then he will start sending the sequence number 3. Otherwise your connection will be timeout and it will be closed. Clear, guys? Okay, no problem. So clear, guys?
Yes.
Oh, yes.
Guys, this is very important because in uh, interviews, right? If the guy is really very pretty much good in TCP and all, and your applications, your systems are most of the times if they are playing around the TCP, then they might ask you bunch of questions in this TCP. Okay, so you should be clear in this. Correct.
Um, Madan, I am not feeling well today.
Okay.
Um,
Yeah, no
shall I
problem.
attend
Yeah,
recording
yeah, yeah, yeah.
class?
Yeah, yeah. You can go
Uh,
through the video and you can ask me the questions in next class. That is also completely fine with me. Okay.
yeah, sure.
But you
Thanks.
guys should go through this video. Okay.
Yeah, sure. It will share by today, right?
Yeah, yeah, yeah. After this session, I will be sharing this video to all of you guys. Okay. No problem.
Yeah,
Kumar,
thanks.
I'm gonna drop off too. I'm having fever, so I'll just have to, you know.
Rubal, you are also not feeling well.
No, I have a flu.
You have flu, man. Okay, man. No problem. So, but
Oh, yeah.
don't miss watching the video, right?
No, no, no.
So,
I'm gonna. Yeah, yeah. I cannot focus. The problem is that I cannot focus on it.
yeah, understood, understood. So,
Yeah.
yeah, no problem. So, I will send
Okay.
you this video later after this
Please.
session. But don't
Okay.
forget to watch this video once you feel comfortable. Okay,
Yes, yes.
because this is very
Thank you.
very important concept. Okay.
Yeah.
Okay, man. Okay, no problem. Take care. Take care, Joshua. Take care, Ahmad. Okay. So we two of the guys remain now. Okay. So you guys are clear now, right? Okay, man. So
Yes.
Yes.
this is very important concept, Enamel and Rahman, because I'm telling you, if the guy is really strong in TCP and if he wants to play around the TCP, right, this guy will ask all this information, all these things. Okay,
Mhm.
okay, and even for your further studies like learning TCP optimization and learning firewall, there also these TCP concepts are really important. Okay.
Mhm.
Okay, guys. So this is how it works: retransmission, timeout, and all. Now let's discuss about the duplicate packets.
Just quick one question. For the
Yeah.
packet analysis, that is very much important, right?
Yes. Yes. For especially when we troubleshooting, right? So that time it would be really very important. If something is the most of the times we will dive into TCP analysis when there is a performance issue. Whenever the performance issue rise, right, we check all the troubleshooting, and then finally we goes to TCP and checks the why the performance is not good. Most of the times we'll do with this with the performance issue like delay, packet loss. We'll check why the packet is getting lost and why this delay is happening. By analyzing this TCP we'll analyze this TCP using the tool called Wireshark. I will install. I will show you how to analyze these packets using the Wireshark later session. In later session, okay?
Mhm.
Okay. So yeah.
Okay.
Okay. Now we'll see what is meant by duplicate packets. If some performance issues are rising, right? So you will receive duplicate packets. Okay. Now we'll see what are duplicate packets and why it is happening. Duplicate packets. Okay. So okay. So we were discussing about the sequence number and all, right? What if this acknowledgement loses? See, we discussed what happens when a sequence number is lost. What happens when acknowledgement is lost? Actually, here your client is receiving the sequence number. The problem is the acknowledgement packet gets lost in the transit. So the server thinks the segment is not reached in the segment was not reached to client. So he thinks that segment 2 is lost, and again what he does, he will again send the sequence number 2. He waits for timeout period. Once this timeout period is expired, server is thinking that sequence 2 is lost, then I have to send the sequence number back to the client. So what happens, he sends the same sequence number, he sends the same sequence number 2 back to client. So this is one scenario, right? If the acknowledgement is lost, then duplicate packet will happen. Okay. The second scenario, delayed delayed acknowledgement, or you can say early timeout. Delayed acknowledgement, early timeout. Okay. What is early timeout? Early timeout means if though you are receiving the acknowledgement, you are receiving that you are receiving the acknowledgement after the timeout period. Let's say if it is 1 microsecond, right? You are receiving the acknowledgement after 1 millisecond, like it takes 2 milliseconds. Again, after this 1 millisecond, right? This guy sends the sequence number 2 back to the client. Correct. So in this case, you are receiving the duplicate acknowledgements. So one is this happens, duplicate sequence number, and in early timeout, he will receive duplicate acknowledgements. These two duplicates are not good. If you see this duplicate acknowledgement and duplicate segment retransmissions and duplicate acknowledgement, right? So you can conclude something is happening in this circuit, something is happening in the link, right? So which means that this is not good. You have to troubleshoot. You have to check what is going on with it. Clear?
Mhm.
Okay. Okay, guys. Now, let's talk about the flow control. So, this is how the TCP works. This is a TCP operation, right? This is how the TCP works. Now, let's say one of the functionalities of TCP, that is, yeah, Rahman, tell me.
Okay, what I meant to say, the way the explanation you were giving me about TCP, right? Transform oriented protocol, right?
Correct.
And if you really wants to meaning the simple way how I'm going to use it and what would be the simple way to explain that TCP. And as you just explained the whole thing that like when we are having an interview in future, whatever, we need those kind of things. And of course, we have to learn it. But what would be the easiest way to impress the interviewer or to understand that
The
particular
point,
things, if you don't mind?
the point is, if you explain all these points, right? See, whatever, see, the fact is that there is even a lot of things involved in TCP. What I'm
Mhm,
giving you is summarized versions of the original version, correct?
mhm,
Because I cannot take each and every pinpoint here, but I can tell you the summarized way how the guy should, what the guy should know, correct? So if you
mhm,
explain this right, maybe if you go through this, if you really understand this, take some time and understand this and tell the exactly what I have tell you. See what I have teach you here. If you explain this in a better way, then the guy will be really impressed, because I'm telling you, because I told you that I have 15 years of experience. In my experience,
mhm,
I have taken a lot of interviews, the juniors, and I have trained a lot of junior engineers while taking into your company. So during the knowledge transfer session, I was taking the sessions, sometimes TCP, sometimes routing. So whatever the topics are given to me, I used to cover that part to my newly joined freshers. So that time, while we are taking an interview, and the guy really understands this TCP, the interviewer will be really happy. Which means he's where, see, the logic behind the recruitment, right? They will have some
mhm,
budget. For example, if I am recruiting Rahman or Enamal, I have some budget for you. For every month, the salary is one part. Another part is how quickly I can adapt this guy into my project. That is one more thing. So I don't want to
mhm,
spend like 3 or 4 months or 5 months to give knowledge transfer. Even if I'm giving some push to this guy, he's not clearly understanding. That's me. That means that frustrates the people, right? And again,
mhm,
they cannot invest that much. These are all kind of billing process. So what they will do, if you are good in concepts, then he convinced her like, okay, I can take this guy, I can train this guy quickly, and I can quickly adopt this guy into my project. This is how the basic logic behind the interview. Okay, so if we explain, see, whatever the things I have explained you so far is kind of the proper way of how TCP works. Okay, though it looks like a long time and it looks like a big process, but this is the straight away. I told you everything straight away. Okay, this is simple and the straight away method of understanding and teaching TCP to someone in the interview. If somebody is asking this, right? If you give all this point, then man, I 100% sure that guy is really impressed on the while if you explain the exactly what I'm telling you here. Clear? You can understand this clear if you study, if you go through many books, correct? You agree?
That's true.
Yeah. So which
But
means this is simple way. This
as
is
I
simple
taking
way.
your classes, right?
Yeah.
As I taking your classes, what I meant to say, like, if you when I'm having discussion in group study and all this, right? So if I have the basic things, making myself like, hey, I get this, and then I have to study that. But you have to stick with something and just go from there. So this is what I meant to say, like, I have to be specific things, and you give me from there and whole explanation. That would be easier for me to like just because I am a very fresher, as I told you. I
Yeah.
have no idea. So this is
Yeah.
why I'm
You
asking
understand.
you also all this question.
Yes. Okay. Let me take a few steps back and let me explain you from where all this TCP started. We are discussing
Mhm.
about OSI layers. You remember in last class?
Yes, Vaisala.
Yeah.
Yes.
So in this OSI layer, we started discussing about layer 4. This is transport
Yes.
layer, correct?
Mhm.
So this is where everything started, right?
Mhm.
Transport layer. I told you there are two protocols. One is TCP, another one is UDP, right?
TCP and UDP, yeah.
Yeah. So now we are discussing about TCP and what are the functionalities of TCP. Once it is done, I will go to UDP. Once it is done, I will go to layer 3. This is how it is happening. This is how the flow is going.
Mhm.
Understood? So it all started.
Yes.
It all started from OSI layers.
But if you like the way you just told me, right? And that would be easier for me to understand, right? As a fresher. And they knows they have more experiences. Okay, that makes sense to me. Yeah, now
Okay.
please go ahead.
No, this is basics, Rahman. I'm telling you, these are all the really very basics, and I'm teaching you what. And I'm taking a very, I'm going in slow, very slow pace
Mhm.
because I told you right. I treat you guys as a fresher and the new guys to the networks,
Mhm.
right? So this is very basics, man, and I'm going slow only. So yeah, as you said, I'm taking the sessions as per the flow, and this is how. So when we are talking about the TCP, this is the TCP, right? This is how it works.
Okay.
So I think you understand. You are following the classes, right? You are following the session, right?
Yes, I do.
Yeah. So no problem. So don't worry. I'm going, step by step only, and these are all the things. See, if you are lost something, somewhere, then just go through the video. Okay, so you will be getting, where you get stuck and or which point you need more explanation. That thing you can ask me later as well. I will teach you. That's not a problem. Okay,
Okay.
okay, okay. So now TCP. I told you in TCP there are it does three things: flow control, congestion control, and error detection. Okay. So what is flow control? So this is client, this is server, right? So what happened? Sin. The first thing is sin, acknowledgement sin and sin acknowledgement. This three-way handshake will happen at every TCP connection. It starts with the three-way handshake. That's why every time I'm drawing these three lines for three-way handshake. Okay. So now what happens? There is a segments 1, 2, 3, 4, 5, 6, right? Now this guy is sending the first sequence number. Okay, I say S1, and this guy acknowledging it back A1, and this guy sending sequence number 2, and this guy sending acknowledgement number 2, right? This guy sends sequence number 3, and this guy acknowledges this sequence number 3, correct? So it goes on till the in this example 6, right? It happens till sequence number 6, and till sequence number 6, and this guy acknowledgement this is sequence number 6, right? So this is how happens in my example, right? So now the question is, if I send each and every segment and getting the
Hmm?
acknowledgement for each segment,
Uh-huh.
hello, yeah. So if I send sequence number one by one, do you think it's an efficient way of doing this? Do you think it's an efficient way of transferring the data? What, uh, for example, for the sake of understanding, I am giving the example of 6 segments, but in reality, you don't know how many segments are there. Maybe 1 million segments, maybe a 1 million segment or 2 million segment. We don't know, right? If this is the case, do you think sending one each and every segment one by one, if you're for example, if you're downloading a movie or some song, right? So if it has 1 million segments, do you really think that sending each segment and getting the acknowledgement and it happens for 1 million is this a really efficient way? It would be very delayed. Delay will be high, right? In this case, if you're sending each segment and receiving acknowledgement, it would be uh, very slow, correct? So instead of what happens if I send a bulk 10 segments each every time, if what happens if I send 10 segments on single go, correct? Instead of sending equal one each segment at every attempt, instead of that, what if I send 10 segments in each go, correct? That would be much efficient way, correct? Make sense, right?
Yes, it makes sense.
Yeah. Now, this is how the TCP started performing at the very beginning stage. Later, they identified that okay, this is not an efficient way. We have to look forward for some kind of new technique. So they came up with the concept called sliding window. So sliding window. Okay. In sliding window, instead of sending single each and every sequence number, what they will do first here, see here there is a field called window size, correct? So window size will tell you how this window size works in TCP. That is what we are going to do. According to this window size, we'll accommodate the number of segments for each transition. Okay. Okay. Let's consider this example. This is client. This is server. This is client. So you are sending the data and receiving the data. So what happens while this guy is sending some sequence number or something, right? This guy will also tells the window size, which means this guy will have the memory. See, if you are receiving some segments, right, it will first save in some buffer, which means some memory, correct? So if you are receiving these segments, this sequence number is nothing but a original data. Segment by segment, you are receiving it. So once this computer, your machine receive it, it will store in some memory, correct? 1, 2, 3, 4. It will receive in this way, correct? So 1, 2, 3, 4, 5, and your CPU will takes this and process it. Then 2 comes here, 3 comes here, 4 comes here, right? Like this, your segment keeps on coming, and your CPU will take this and it will process, right? This is how it happens, correct? So now the thing is, instead of sending each and every sequence number, correct? If I tell my server how much space I have in my memory, or let's say 1024 bytes I have space in my uh, receiver side, or if you say, for example, you can say like, okay, I'm telling my window size, hey, I have 2 MB of space in my memory. Now you can send me the segments which you can accommodate. You can send me the segments which can accommodate 2 MB now. So now what happens? Each segment is 1,500 bytes, correct? Now you can send you can send the segments which can depends upon this window size, correct? If 2 MB space is there, maybe you can accommodate 3 segments, 4 segments, 10 segments, like that, and you can send this sequence number in a single go. That is how the TCP window size works. In TCP header, you see the window size, right? That window size is nothing but you are telling your server how much space you have in order to receive the segment. Clear? So depends upon the memory size available. We call it as window size. The meaning is that the space, the amount of space available free in this client side. Okay, you are just informing the server, hey, I have this much of space. Just accommodate the number of segments depends upon the space available. That's it. Clear? It seems like you are traveling from one place to another place. The guy will accommodate you depends upon the number of seats available. Correct?
Mm-hmm.
So in the same way, this guy tells, "Hey, I have this much of space is available. Just accommodate the number of segments depends upon that." Right? Before that, there was no system like this. This guy will keep on sending the sequence number 1, 2, 3, 4, and this guy is keep on acknowledging the sequence acknowledgements. Okay, this is very early stage of development. It was happened at very early stages. Okay, now they saw some kind of inefficiency, then they came up with this idea that we call it as sliding window. Clear? Instead of single packets, and you will be sending the number of packets depends upon the space available here. Clear?
Mm-hmm.
Okay, now this is called flow control. This is how the flow happens. Here, one more problem. They see one more problem, right? So so far so good.
Yes.
Yes, this TCP and this OSL layer will be more, you can see more theory in this OSL layer. Once it is done right, then the practical part will be really good. So you can enjoy that. So be patient for until I complete this OSL layer. Okay.
It's a long process, as you know.
Yeah. Man, we cannot do
Yeah.
anything, man. I'm also helpless. You, that is, so that is what you are paying for, right? So my duty is to cover all the things. Okay, so now you are sending segments, right? So I'm skipping this three-way handshake every time. No need to draw that, right? So I'm skipping that part. Let's say the client is sending, sorry, your server is sending. 5 segments. This is S equal to 1, S2, S3, S4, S5, right? Instead of sending one segment, now you are sending 5 segments, because your client is telling you, I have the window size, okay, window size available, you can accommodate 5 segments in this window. Okay, so you can accommodate to sequence number 1 to 5, you can accommodate in this window. So this guy is accommodating all these segments and he is sending. Now instead of one segment, you are sending 5 segments, right? Now what happens? This guy has to acknowledge back for each segment. Okay, so this is A1, A2, A3, and A4, and A5, correct? So, which means, why I am telling you this window sliding window, right? So, this is your segment. They consider it as a slide. Okay. So, 1, 2, 3, 4, 5, 6. Okay. Depends upon this window size. You will fix the slider, which it's a concept. That's it. So now, how many segments I sent? 5 segments, right? I sent 5 segments. Okay. Now what? Which means your window size is 5. Your window keeps on moving here. So which means you are keep on sending this 5 each time, 5 segments each time, right? So this guy keeps on sending the data, keeps on sending the segment, and this guy keeps on acknowledging the segments. This is how it happens. Okay. So now what happens? What if I lost this segment number 4? What if I lost the segment acknowledgement number 5? Again, I have to retransmit from the place where I lost the packet, right? If I lose segment number 4, example, then the slider has to come back and he will start from 4 to 4, 5, 6, 7, 8, right? So I have to send from 5 segments, 4 to 5, which means 4, 5, 6, 7, 8. So this is 5 segments, right? So this is what happens at the early time, and they invented the concept called SAC, which means selective acknowledgement. Selective acknowledgement. They made life very easy, which means if you lost segment number 4, then particularly this guy will send that particular segment number 4, and this guy will acknowledgement for that only that acknowledgement. Sorry, segment number 5. Okay, so whatever whatever the segment you lose, right, the server will send that particular segment. That is the meaning of selective acknowledgement. So if the segment number 4 lost in the transit, right, then you will not be receiving this acknowledgement number 4, and you are receiving the acknowledgement number 5, acknowledgement number 6, acknowledgement number 7, but not acknowledgement number 4. So the server understands, okay, so I'm receiving other acknowledgement back, but not acknowledgement number 4. Then what I will do, I will retransmit that particular segment. I will send that particular segment number 4, right? I'm selecting this acknowledgement, and depends upon that I'm sending that particular segment. That is called selective acknowledgement. Clear? So this is the efficient way of transmitting the data from source to the destination. So this is called flow control. This is how flow control works in TCP. Clear, guys? And some and people call it as fast retransmission as well. So you're sending the segment, bunch of segments on each go, right? That is called fast transmission and fast retransmission and all. Okay. So, any questions, guys? So far, flow in flow control. This is very simple thing. You feel heavy because you are listening everything in single go, right? In 2 hours, you are listening all this, and you are facing some heat while how to remember this. Don't worry. Just keep a focus while I'm teaching in the class. Okay, so that the logics and the explanation, the concepts you can understand. Try to understand the concept, and again, if you're going through in the second attempt, right, then one by one you will clearly understand. Clear?
Yes.
Okay. So this is for the flow control. So next is, so the second one is congestion control. Okay. So congestion control means it uses the slow start algorithm. It uses the slow start algorithm. See, these TCP concepts are really very important for security, QoS especially. So these two areas where the TCP remains very important, and this congestion control is very much important for quality of service, that is QoS. Okay. So okay, let's say your client, your server is sending the data. How your data gets accelerated, right? It's a kind of slow start, meaning that how your TCP works in order to avoid the congestion. Okay, see, after the three-way handshake, this guy sends sequence number one. This guy acknowledges sequence number two, right? After that, what happens? Sorry, this guy sends acknowledgement number one. Now this guy sends two sequences, S1, S2. This guy acknowledgement for acknowledgement one, acknowledgement two. Okay. So this guy receives two acknowledgements. Now what happens? Now this guy sends four. On every attempt, he is doubling the size. Clear? Now one, two, three, four. Now you will be getting four. Four acknowledgements. Okay? Means one, two, three, four. Okay, first attempt 1, second attempt 2, third attempt 4, 8, 16, 32. Right? First he sends acknowledgement number 1, 2, second time he's sending two acknowledgements, right? First one, now after you receiving the acknowledgement two acknowledgements successfully, now this guy sends four acknowledgements. Right? In the same way, 1, 2, 3, 4, 8, 16, 32. It keeps on accelerating on every attempt. That's why I put it as exponential curve. Clear, guys? So how long it goes? It goes till your bandwidth of the link. Okay. This happens, for example, this link is 100 Mbps, right? If this link is 100 Mbps, correct? If this link is 100 Mbps, how long you can send? Till the data that 100 Mbps link can accommodate, correct? Correct, guys?
Mm. Yes.
Okay, so it keeps on accelerating the data like 1, 2, 3, 4, 5. Once it reaches the max out, then your segments will be choked, right? So the link is choked basically. This link is basically choked. From this point, you are receiving duplicate acknowledgement, right? Duplicate packets and all happen here, duplicate packets, right? So you will receive once you reach the maxed out, correct? We discussed early. I'm getting the duplicate acknowledgement, right? Duplicate acknowledgement for early timeout and duplicate packet for the losing of acknowledgement, right? And a retransmission packet means if you are not receiving the if you are not receiving the segments, if you lose the segment in the transit, then you will receive so much of retransmission packets, correct? All these things happen when the TCP reached its maximum limit. So by that time you should understand, okay, the link is exhausted, right? So once it reaches, what happens? Your TCP reduces the window size. Okay, for example, by the time your TCP reaches the maximum, here, if it is 1000, right? By the time you are reaching this limit, you are sending the each 10,000 segment on each go. Once this your TCP senses this duplicate packets and duplicate acknowledgement and retransmission timeout, then what it happens? It will reduce the transmission by half of the original. For example, by the time it reaches this threshold limit, then once you receive the duplicate packets and all this, then your TCP reduces this by half of 1000, which means 500. Now what happens? Your retransmission will get back to 5000 or 500 packets. Again, slowly it will increase the session. Keep on throttle this, 500, and again it starts from again sequentially it will increase the segments. Once you started feeling this errors, right, then it will slow down, then it will increase, then it will slow down, then it will increase. So this is called slow start algorithm, and this graph looks like a sawtooth. Clear? So this is called congestion control. Guys, I tell you, if you explain all this in your interview, right, then straight away this guy will pick you. Because I know how long I'm going and how depth I'm telling you, I know, right? So that's why these are really precious things you need to understand and remember. Okay. So this is the congestion control in TCP. Okay, this is enough. We no need to go beyond this. Okay, so this is enough. So if you remember, this is far enough. So this is how your TCP handles the congestion. Congestion means what? So many packets and attempting, right? So all the packets try to go inside the circuit and all. So how you manage that congestion? This is how you manage the congestion of packets. Clear? Clear, guys? And the third one is error control. Error control in the sense error detection. So error detection is nothing but, so you're finding all this loss of packets in the transit, right? That is what this guy means, error detection, nothing else. Clear? So in TCP, we saw, by the time, I hope you understand what is TCP port, what is sequence number, what is acknowledgement number, what is the window size used for, what is fin packet, right? Fin packet is used, so like how we establish the connection, we use a SYN packet and acknowledgement packet, right? In the same time, in the same way, the fin packet will be used at the time of connection closure, closing the connection. This is a SYN and acknowledgement used for connection establishment. Connection establishment. Okay, and fin plus acknowledgement used for connection closure. Connection closure. Clear? So this is the combination bit. Then reset. When the reset will be used? Okay, let's say this is your computer. So firewall is placed in the middle, and this is your internet. This is your internet. Your firewall, you are connecting to firewall, and firewall is connected to internet. Right? Let's say I blocked the FTP. This firewall, you are denying the traffic for FTP, which means FTP is what? File transfer, right? This is used for, this is file transfer protocol. Uses the port number 21, right? So if any packet, TCP packet, right, goes with the destination port number 21. If it is file transfer, it uses the 21 port number, right? If any packet comes to the firewall with the destination port number 21, then this guy will block this packet. Correct. That is what the firewall does, right? It blocks the unnecessary traffic. Whatever you write depends upon the rule you are writing in this firewall. Correct. If you write a rule to stop passing to stop passing a destination port number with the 21, which is FTP, this guy will block that packet. If that happens, then the packet will be marked as reset, and it will be sent back to the client, and he see, okay, my packet is resetted, so which means something is blocking my connection. Clear? Clear, guys? So these are the flags you need to remember. We'll discuss this ECE and CWR in while we discuss about the QoS. This is explicit congestion explicit congestion notification. This one is congestion window reduction. So these two guys will discuss during the time of QoS. Now these are the flags, very much important. So the push flag is nothing. You are just pushing the server clear the buffer, or server is telling the client, hey, I'm sending the segments, bunch of segments, please clear this buffer as soon as possible, so that this computer gives priority to this to clear this buffer, which means you are pushing your client to clear the buffer. So if you enable this flag, then that will happen. It's kind of push, that's it, pushing the client to process quickly. Okay. So urgent pointer and all no need, because nowadays no system, no networking device or systems using this urgent pointer. So no need of going through this urgent pointer on the urgent flag. Clear? So this is all about TCP session. Okay, TCP header and all. Clear, guys?
Yes.
Okay, so let me show you the Wireshark tool. Shall I take it now, or shall I take it next class? Because other people can see, right? Or if it is okay, fine then.
Yeah, at least you can show
Yes,
how to
yes, yes.
install and everything.
It's simple, it's
So,
straightforward. It's very much straightforward.
yeah.
Mm, go to the browser. It's very simple. Download Wireshark. Go here. This is the official page of Wireshark site. Go here and just click Windows. So this one is for DMG is for Mac. I don't know why I clicked this, I think. So go here and just install it. Very much straightforward. Nothing. Kind of simply how you install the software, right? So simply install that software, and this will be, you will be getting this. So once it is done, then double click it, then it will open. It will ask you which packet you want to capture. Okay, so I will capture the packets going via my Wi-Fi. If I click it, see, you are seeing plenty of things here, right? So, and I stop here. If you want if you want to monitor any particular TCP transaction, okay. So these are all IP version 4. Nowadays, everywhere IP version 4 started using. Let me show you. Let me find some TCP. Okay, what I will do, let me readily open the browser. Let me capture this transaction. Okay, so I'm started capturing this. What I'm going to do, let me connect to the Cisco server and let me connect it to uh, some local here some local websites. Okay, so these are the two sites I'm reaching now, right? Which means my TCP will capture these two traffic now. Okay, okay, now I'm stopping it. Okay, so open this and started browser there. Browse your this thing, right? So see here, the reset happened, which means someone is blocking this connection. That's why it says reset. But before that, I want to show you. Okay, this is multicast address. So nothing doing with this. Okay, so let me take this transaction, go here, follow TCP stream. Okay, let me follow this stream then. Follow TCP stream. So port up. See, I told you FINAC, three-way handshake for connection closure, right? Okay, let me firstly start one more session because there are plenty of sessions was going on. Let me go through few things behind website.com. Let me say that any other. These are all some kind of local sites. And Cisco.com. Let me say YouTube. I think YouTube will also use the application for. Sorry, I have to start capture and doing this, right? Capture. Okay, now let me generate some traffic. right? So I'm doing this. Oh, let me stop. Now I have captured the packets. Let me follow. This is UDP. Wait. I hope this helps us. This also UDP. Okay, I think this helps us. But only 2 packets. That's okay. So just wait, guys. Just to keep patient. So I need your some patience here. So you see duplicate packets and retransmissions. So few packets are dropping here. This is the thing. See, now let's analyze this. Just keep some patience. Okay, so while because there are plenty of thousands of packets are coming on, right? So show some little bit patience here. Let me take this stream. Okay, here what's happening? My source IP is 192.16.168.29.254, right? And my server is, this is my server. My server IP is, the destination IP is this one, which means 162.251.5.141. This is my server, right? So the very first thing what is happening, SYN, signal acknowledgement and acknowledgement, right? From my client to server, right? My client to server. What is the packet you are seeing? SYN. This is my source IP. This is my destination IP. SYN is going, correct? And my server replying back with SYN and acknowledgement, right? Acknowledgement plus SYN. And this guy reply back with acknowledgement. Correct. These are the first 3 packets happening. This is called three-way handshake. Correct. Clear? So once this is done, again, so these are all your sequence. So I told you it will send the bunch of segments depends upon the window size available from the computer, correct? From the client, right? Window size. So that is the window size here. Okay. So he says 62652, okay, and 80. This much of window size is available. So what this guy will do, okay, I will send the segments like this much segments I can send you, right? From sequence number 1 to 5000, this many segments I can accommodate in this buffer. So that is what it says, right? And again, this guy will send that much of data and these things will happen. Let me explain one by one. So if I take this first packet, my flags are, see, SYN packet is set, In second packet, SYN pack, this acknowledgement and SYN is set. In third packet, my acknowledgement is set. These are the flags, right? And my source port number is 52110, destination port is 114, correct? So this is my source IP. My source port number is, this is my source port number, 52110. This is my source port number. And my destination IP, this is the destination IP, and destination port number is 443, which is HTTP. Okay, so this connection, my SYN flag is 1. For this connection, SYN and acknowledgement packet is a flag is 1. For this one, acknowledgement flag is 1. Okay, guys, you guys understanding this correct? Hope you are clear. And
Yes.
so next packet, if you see, this is my window size available. Where is that? Yeah. So this is my calculated window size. 65280. This is my window size. Okay. So here my sequence number is 1. So see, Wireshark is helping us to understand the flow better. Okay. Actually, I told you the sequence number starts with some random value, correct? In order to avoid our data to be hijacked, right? So the original sequence number is this one. This is 32-bit, right? So this original number sequence number starts with this one. But what Wireshark helping us know, it will tell us it's a sequence number 1. That is why it is a relative sequence number 1. Okay, it telling us 1 because that would be easy to remember and easy to analyze. See, every time I cannot go with this sequence number, I can say this one, right? So every time I cannot check with this number. Instead, Wireshark is doing some help for us. Instead of saying this number, let's assume this is 1 because anyhow this is your first sequence number, right? So that's why this is how your first segment, right? So let's say it's a 1 for us, but the real sequence number is this one. Okay, so I'm saying that my next sequence number is 1790, which means he can accommodate 1 to 1089 segments. He can accommodate with the window size of, okay, with the window size of 65280. This is my window size. In this window size, he says I can accommodate till 1789. These much segments I can accommodate. Okay, and this window size is not same every time, right? So you cannot say your CPU will clear all the buffers at a single go. Sometimes the CPU is processing, so sometimes it would be 65208, and another time, so this is the first, and another time the size is reduced, right? It depends upon, and again your window size is increased. So it depends upon the how much memory available at the client side. Depends upon that, he will he will inform the server and he will adjust the sequence numbers. You understood? So this is how the TCP session works, and your data, actual data, will be sent from one end to another. Clear, guys?
Yes.
Okay.
Yes.
Yeah, I understand. I understood that today is heavy for you, but take some time and go through everything. Okay. I know, man. So every day you cannot dump yeah, everything on single day, right? I understand, but the TCP, this is how. Even if I delayed, right, then it will take even longer time. So you are altogether you have to spend more time. Okay. So in summarized way, so I try to put everything in simplest way and try to understand in simpler form. Okay. Clear, guys?
Okay.
Okay. Now let's see other things. The reset flag and all we did not see, right? Let's move and check. We discussed a lot of things like retransmission, this, that. I think there is no problem in this. If you say red line, right, that is something is wrong. See, if you see this guy, so one, uh, okay, let me explain this. What does it mean by reset with this? Okay, here the source is there 192, 168.29.248, and your server is right. This is your server. IP is 162.241.5.14. Okay, this is your source IP, correct? This is your destination IP. So if you see the reset, right, which means some networking device in between these two guys, probably it is firewall or something is blocking the connection. Okay, what happens? And this guy's port number, what is the port number for this guy? It's a TCP port number only, but let me see what is there inside. Okay, port number 443 only. So this is 443.
I have one question.
Yeah,
So the port number is 443. That means the HTTPS.
yes.
That so that is should be the very secure, right? So if that is connection is very secure, how come somebody
Okay.
can enter between?
Yeah, good question actually. So this is 52110, correct? So this connection is blocked somewhere in the someone by some devices. From any network device, someone is blocking. So see, even if it is 443, it is HTTPS, right? There are various reasons the guy can block this. Okay, this is just a TCP session. Inside this session, there is layer 7, so layer 7 is there, right? Inside this, maybe you are allowing this 443, but you are not allowing a few protocols. Like for example, a few websites. For example, the websites, maybe if I block this YouTube, right? Only this your www.youtube.com only blocked. Only this URL is blocked. It doesn't mean you are blocking entire 443. Correct? Understand? So if I block Facebook,
Yes.
so if I block Facebook, right? The Facebook works on 443 port number, but I'm blocking only this website, which means www.fbfacebook.com. And rest of the website like www.cisco.com will work. This is what, because you are allowing this, and this guys you are blocking it because if I allow this, your production will be disturbed. Instead of working, you guys will see Facebook and chat, and you always watch YouTube. Then this is the loss for the company, right? So that they will block the sites which eat up the time and which eat up the bandwidth. Okay, so maybe these guys they are blocking this. Okay, the reason is that something is blocking and we don't know the reason. So that's how you need to analyze. So the guy might tell you, hey, I allowed 443, but this connection is not establishing, it is getting blocked. Then what you guys will do? You will do the Wireshark.
No problem.
Okay, so yeah, what I was telling you, yeah. So you need to analyze this first, correct? So go here, do follow TCP stream and see what's going on with this. Okay, so the entire thing, so the TCP session is formed and all your transactions are happening. all of a sudden the connection is blocked. And actually what happened, it is properly uh, it closes the connections properly. See, I told you the way how the TCP established the connection, right? The way how the TCP established the connection, right? The same way it will close the connection. So I told you this is a three-way handshake using fin, right? This is the server. So this guy says fin, this guy say fin acknowledgement, fin plus acknowledgement, and this guy say, sorry, this guy say acknowledgement, right? This is again three-way handshake, three-way handshake closure for TCP closure. Okay, clear guys? So this is how happening. Once it closes and it sets a reset. I think it's obvious after closing the connection, there are some machines. It will close the reset the connection, which means the connection closure. Okay. So again, this will happen if in this scenario as well. Even though you allowed TCP 443, if you allowed any specific URLs, that URLs will be inspected by the firewall and it will block that TCP connection. That time also you will see the reset. Clear?
Mhm. Yes.
Okay. So if you see fin acknowledgement, then the flags fin is set, right? So flag A and F. Okay. Let me see any retransmission packets on all. Yes, Anamol, tell me.
Yes, so I encountered something last week in the office. This is
Okay.
what I'm trying to
Mm-hmm.
understand now. So my client is FFA.
Mm-hmm.
So and the laptop, this is from the L3 Harris, and the YouTube is okay. I can watch on the YouTube over there.
Mm-hmm.
So to understand the FFA, how it works, their structure and
So this guy UDP, if live feed is there, if feed is there, right? And many people are watching the uh, movie, sorry, many people are watching any football match or cricket match. This feed is continuously sending the data. So that is UDP packet. Everybody will receive that. Okay. So this guy keep on sending, this guy keep on receiving. Now also in our meeting, so I am giving you the session. You three guys are receiving, right? Watching this. So which means I'm keep on sending the data. You guys are keep on watching this, receiving the data. That's it. So this is done by UDP. So there is nothing much in UDP, but you have to go through many things in TCP when it comes to TCP because this is reliable and connection oriented. That's what. Clear?
Okay.
Okay, guys. So this is what for today, and next class we'll discuss layer 3, layer 2, and layer 1. So there is nothing much in layer 3 and layer 2. Layer 2, I'm not going to discuss in detail because the switching part is there. Okay. In switching, anyhow, we are going to study the entire Ethernet frames, how it works, and what is the field inside. What is the meaning of each field inside the Ethernet frame, right? So that will be we will discuss in switching when I start the switching. This is the first class of switching. So no need to discuss all this in deep right now. We'll discuss that in switching part. And L3 also, we'll discuss the header and what is there inside the header. We'll discuss this in detail, but this does not have the information we have in TCP. This is not that much detail, but we'll be the next class. We'll see the other layers of OSA layer. Once it is done, then we'll get into the configuration, router, and switching part. Okay.
Okay.
Okay, guys. I hope you this is informative for you. We'll meet in next class. Okay.
Okay then. Yeah.